It's the chapter of kinematics. We are doing exercise 16.1 from AdMath book, Cambridge AdMath book. This is actually Cambridge kinematics and the ADXL kinematics are almost the similar concept. Those are studying in any Excel or any other board. You also can use that the questions we are solving right now. Here the first question is given here, velocity expression is given v equals to 50. That is the velocity expression, and let me read the question. Find the velocity of the particle as it passes through O. It passes through O means it started from the point O. 30 seconds after passing through O, it is written there. Then at the point O, actually t equals to 0. So the first question they're asking to find out the velocity at the point t equals to 0. Let me do it. We are going to put in the expression value of t equals to 0. So 50 divided by 0 plus 2 square, and it is 50 by 4, which gives us 12.5 meter per second, and its unit is meter per second because it's the velocity. First question done. Then the second question, find the value of t when the particle velocity is 0.15. It's easy. Velocity value is given. We are going to put it instead of v to get our value of t from here. The expression is 3t plus 2 whole square, and on the right side you can write it 0.125. So in that type of equation, we do not need to break down. Let me make 3t plus 2 as a subject directly, equals to, which is 50 by 0.125. Better to use calculator and check what is the value coming out from there. If we use calculator, which gives us 50 divided by 0.125, 0.125, and it gives us value is 400. Let me write here 400 on the right side. 400 you can write here 20 square, because 20 square is for there, therefore it is the value actually 50 plus 2 equals to plus minus 20. You can write 30 equals to minus 2 plus minus 20. We are not taking the negative one because time would not be a negative value, but it is a positive now. Minus 2 plus 20 divided by 3, which is 18 by 3. It gives us 6 seconds, and this is our answer in this stage of this question. Then the last question, it is written here, find the acceleration of the particle, but the expression here given velocity expression. So to get the acceleration, we needed to differentiate it. So let me differentiate to get the acceleration part. Acceleration denoted by a, we need to differentiate of that expression. d by dx of velocity expression, it is given here 50. Let me write like this, 30 plus 2 to the power minus 2. Now we're going to differentiate it. It gives us minus 50 into 2, which is 100. Then 30 plus 2 minus 2 minus 1, which is minus 3, into inside if we differentiate, we got from there 3. So our final acceleration part, we can write it minus 300 divided by 30 plus 2 cube. Now the question is, they are asking to find out the acceleration at the point t equals to 1. We're going to put here t equals to 1. Let me write when t equals to 1, acceleration equals to minus 300 divided by, we got 0 plus 2 to the power cube, and it gives us minus, let's use calculator again to get the value from here, which is minus 300 divided by 8, and it's the value 75 by 2, or minus 37.5, minus 37.5, and its unit is meter per second square. Hope you understood. Sorry, here the negative sign actually showing that part is the deceleration, but it is written here acceleration. This is the first question that we have done from here. Let me move to the second question. In question number 2, it is written here. Again, velocity expression is given here. So they're asking to initial velocity. Actually, initial velocity, we know t equals to 0, we need to apply. Because passing through O, it is started from the point O. So let me put here t equals to 0, then we got the velocity initial. 6 into e to the power 0 minus 2 into 0. We know e to the power 0 equals to 1 and gives us 6 meter per second is the answer of the first part. Then it is written here initial acceleration. So for x, we need to differentiate it to get the acceleration. If we differentiate the velocity part, and it gives us 6 to the 12 e to the power 2t, then minus 2. This is the acceleration expression. Now we have to put here t equals to 0 again, because it is written here initial acceleration. Then let me put here when t equals to 0, acceleration equals to, you can write 12 to the power 0 minus 2, which is 12 minus 2, the value we got from here 10 meter per second square. And this is the answer of this question, because we know e to the power 0 equals to 1, we applied here. Anything power 0 equals to 1, we applied here. So this is the type of the question. I think you feel easy the question we are doing right now. Let's move to the next question, question number 3. In question number 3, we are going to solve right now. 3, it is given here. Velocity expression is given here in terms of t. The first question, find velocity at the particle when t equals to 100. This is the first question. We do it. T equals to 100. So velocity equals to 5 bracket 1 minus e to the power minus ln 100. This is the expression. So we can use calculator, or if you wanted to do manually, then it should be minus e to the power ln 100 to the power minus 1. So this gives an ln cancel out, which is 5 bracket 1 minus 100 to the power minus 1. That expression is remaining here. We can use calculator. If you use calculator, but in the first part we also can use the calculator. 1 minus 5 into 1 minus 5 bracket 1 minus 1 by 100, you can write that expression 1 by 100. And it is 99 by 20, which is 4.95. So let you write 4.95 meter, and it's the exact value from this question we got. And the second question, state the value which b approaches as t becomes very large. Actually, t becomes very large means we need to consider time, infinity time, big time here. Let me do this expression. This is the question number b. In that stage, we have to put 5, and you can write the expression 1 minus 1 by et. You can write it. So instead of t, if we put here infinity, then actually it gives us again infinity, which is 1 minus 1 by infinity. And 1 minus 1 by infinity, actually 1 by infinity is 0. So we got from here the velocity is 5 meter per second. Actually, the main thing is, if any expression you got 1 by infinity, then it tends to 0. This is the logic we have to apply in this question. In this stage, question number C, it is written here, find the acceleration of the particle when v equals to 4. From the velocity, we needed to collect the time for using in the acceleration expression. First, let we see what is the t part from here. Let me write here, velocity is given 4, so you can write here 5, 1 minus e to the power minus t, and his value is given here 4 meter per second. So let me do it. Then 1 minus e to the power minus t, which is 4 by 5, we can write 0.8. Then from there you can write here e to the power minus t, which gives us the value 0.2. This is the e to the power minus t value. So we can write here e to the power t now reciprocal of the right side, which gives us 5 from here, because 1 by 0.2 it gives us 5 definitely. So this is our value of e to the power. Let me keep it in that stage to get the acceleration of this expression. So now for the acceleration we needed to differentiate first for acceleration actually. So 5 is a constant, let me write 5, then 1 gives us 0, and it is having with the plus, because e to the power negative t there is a minus sign from there, then e to the power minus t. So our acceleration is 5 e to the power minus t. Now we can write here 5 into e to the power minus t value is 0.2. Let me use here 0.2, and it gives us 1 if we multiply. This is the acceleration meter per second square in that stage. And the last question, it is written here, sketch the velocity time graph for the motion of the particle. Velocity time graph, actually you needed to know the exponential part, how to draw the exponential part. So I'm going to draw it up above the t, above the question A, and how to do that question to exponential part. See my working. To do that, velocity expression you can write as a 5 minus 5 e to the power minus t. And we know exponential negative curve, actually how to draw the exponential. Step by step we have to do that. Actually, if any exponential negative curve is given, it with the having with the negative side, positive side, it looks like that. It is going like this way. But due to the reason of time axis, we would not consider the left side. So you cannot draw like this. Only the right side we have to draw, which is this. This is the curve, and it crosses at the point 5. I have done the part 5 e to the power minus t still now, and in front of it there is a minus sign. Minus sign means it goes to the reflection right now. So if I reflect this curve, then it goes to from minus 5 it started, and it goes till to here, and here actually x-axis is the asymptote line still now, which is minus 5. Now it is given here minus 5 e to the power, then plus 5. Plus 5 means we needed to take it 5 up, as well as asymptote also goes 5 up. Let you erase the previous part from everywhere, and we are going to draw the final finished part, and it's asymptote in the line. This is the asymptote line, which you can write y equals to 5, and curve from the 5, it goes 5 up, then curve would be looks like that. And this is our final curve equation of the velocity time graph. We needed to give your velocity v, and time axis is time in second, where is y equals to 5 is an asymptote line, and curve started from the point 0. Hope you understood the questions. We have done question number 3. You will get some other tutorials from this exercise in my next videos. Thanks for watching.